Hi everyone and welcome to the Learning Curve. As part of my series on quadratic equations and factorization, I will be looking at some sample questions from the Caribbean Examination Council, CXC, which often includes factorization questions in the CSEC examinations in the Caribbean region. These questions typically involve different types of algebraic expressions, such as those that can be solved by finding the highest common factor, by grouping, or by recognizing a difference of two squares. In this lesson, I will be illustrating three of these situations, starting with this one. So factorize completely 6y squared minus 18xy. When you have an expression like this, what you need to do is to look at the terms in the expression and find out, ask yourself the question, ask yourselves, is there a term, is there an expression that can be divided into both of these terms? And what you want is not just an expression that can go into both of these terms. You want the highest term that can go into both of them, which we call the highest common factor. This one is fairly simple because we recognize that firstly y is common to both 6y squared and it's common to negative 18xy. Additionally, we recognize that 6 can be divided into itself once, and it can also be divided into negative 18 three times. So the highest common factor is going to be 6y. So we factor out 6y. Factoring out 6y means now that we're going to divide 6y, which is the highest common factor, into both 6y squared and 18xy, negative 18xy. 6y can be divided into 6y squared y times, and that's because 6y multiplied by y will give us 6y squared. In other words, y will divide into y squared y times, because y multiplied by y is y squared, and 6 divided into itself is 1. So we'll just get y as our result when we divide 6y into 6y squared. Now, we now need to divide 6y into negative 18xy. 6 divides into negative 18 negative 3 times, because 6 multiplied by 3 will give us 18. Y divides into itself once, so the y would cancel, but the x would remain. So that would be 3x. So essentially what we have here are the factors 6y, and y minus 3. These are the factors of this quadratic expression. So we have 6y and y minus 3. These are the factors which we could set equal to 0. So we could say 6y equals 0 and y minus 3x equals 0. This would typically be done when we want to actually solve for the values of x and y. So the factors of this quadratic are 6y and y minus 3. Now let's look at the second quadratic expression that we have here, 4m squared minus 1. The first example that I used here was an example of a situation where we simply found the highest common factor, factored it out, and divided that highest common factor into both of the expressions in the expression that we were given. In this particular scenario, we have 4m squared minus 1. And when you have a situation like this, you need to recognize that this represents a difference of two squares. So a difference of two squares would normally be written like this: a plus b. This is like a general format for writing a difference of two squares. A plus b bracket a minus b. This is a general form for writing a difference of two squares. So when we have an expression like this, where we have a variable squared minus a constant, then this is suggesting to us that this could be written as a difference of two squares. So how we write this as a difference of two squares is that we will need to take the square root of both terms. So we'll take the square root of 4m squared, and we'll take the square root of 1 itself, not negative 1, because the square root of negative 1 would have to be evaluated as a complex number. So the square root of 4m squared is simply going to give us 2m, because the square root of 4 would give us 2, and the square root of m squared would just give us m, because the square root of a square term eliminates that square term. So we're left with 2m. If we were to multiply 2m by itself, we would get 4m squared, which is the term that was square rooted. So this is indeed correct. The square root of 4 again is 2, and the square root of m squared is just m. So the square root of 4m squared is 2m, and the square root of 1 is always 1, because 1 multiplied by itself will always give us 1. So now we've found the terms, which would be like a and b in the generalization that I just wrote. So the difference of two squares here would be 2m minus 1 into 2m plus 1. And that's the answer. Those are the factors of this quadratic. 2m minus 1 into 2x plus 1. It doesn't matter whether you could have written the 2m plus 1 first and the 2m minus 1 after, 2m minus 1 second. It doesn't matter because the order of multiplication does not matter. So you must recognize that when you have a variable, the variable here being m squared minus a constant, you must recognize that that is indicating that it can be written as a difference of two squares. And to do that, what we do is to simply take the square root of both terms. The square root of 4m squared in this case, the variable component, which gives us 2m, and the square root of positive 1, which gives us 1. And then we simply write the factors as this number, this expression, minus 1 in bracket as one factor, and then the second factor would be this expression plus 1, which is consistent with the generalized form for differences of 2 squared that I indicated earlier, which is a plus b into a minus b. And those are the factors. The factors of 4m squared minus 1 are 2m minus 1 into 2m plus 1. And I just want to make it absolutely clear that as far as number 1 is concerned, the factors are 6y and y minus 3x. It is not absolutely necessary to write these pieces that I just erased if it is that you're just asked for the factors. But if you're asked to solve, factorize and solve, then you would need to set each of the factors equal to 0 and solve for the unknowns, if you were asked to both factorize and solve. But if you're simply asked to factorize, it is sufficient to leave the answer in this form. So these are the factors for 4m squared minus 1. They are 2m minus 1 and 2m plus 1. Then we look at a third quadratic equation here, 2t squared. So t is our variable in this case instead of x, and that's perfectly fine. The variable could be anything. So this is 2t squared minus 3t squared minus 2. So the first thing to recognize is that this is a quadratic equation in standard form. The standard form is ax squared plus or minus bx plus c. So this is a quadratic equation in standard form that we're going to find the factors for. So to treat with quadratic equations in standard form, what we're going to do is that we're going to first multiply a by c, but we need to identify what is a, what is b, and what is c. In this quadratic equation, a, which is the coefficient of the variable, is 2. So a is 2, that's the coefficient of the variable. B is the coefficient of the variable squared, specifically, that's 2. The first term here, which is similar to this, A. Then B is the coefficient of the variable without the square, which is in this case negative 3, right here, it's B. And C is our constant, so C is our constant. So when you're factorizing a quadratic equation that is in its standard form, ax squared plus bx plus c, you write down the values of a, b, and c. Then the next thing that you want to do is simply to multiply a by c, which in this case is 2 multiplied by negative 2, which is negative 4. And then your aim is to try and find two numbers that can be multiplied to give negative 4, which is the value of AC. But also, those two numbers, you must be able to add them to give you B for it to work. For those numbers to be acceptable, for the two numbers that you find to be acceptable, they must meet two conditions, which are that when you multiply them, you get AC, and when you add them, you get B. What I recommend in these situations is that if it's difficult for you to think about it mentally, that is, if it's difficult for you to find those two numbers mentally, I'd recommend that you simply write down the two numbers, write down all the pairs of numbers that you can think of, that you can multiply to get AC, and see which two adds to give you B. So let us think of some numbers here. Let us think of, for example, negative 4 multiplied by 1. Negative 4 multiplied by 1 will give us negative 4, which is AC. And when I add negative 4 to 1, I will get negative 3. So negative 4 and 1 will work. Those are satisfactory. So the first thing, again, when you're factorizing a quadratic equation in standard form is to write down the values of A, B, and C. Then multiply A by C. Draw a little t, if you will. And then you want to find two numbers that can be multiplied to give you the value of AC. But importantly, when you add those numbers, you must get B. And those two conditions must be met in order for you to use these two numbers to assist in finding the factors of the quadratic equation in standard form. So what we're going to do now is that we're going to rewrite this quadratic equation. So we're going to rewrite this quadratic equation as 2t squared. And what I'm going to do is that I'm going to use the negative 4 and the 1 to replace the b term, which is the negative 3t. I'm going to use the negative 4 and the 1 to replace the middle term here, negative 3t. And that is why it was important that the terms that we found, the numbers that we found, when we add them, we get B. That's why that is such an important condition, because we use them to substitute into the quadratic equation to replace the middle term, that is the term in B. So this will be 2t squared minus 4t. We're expressing the 4 now in terms of t because we're using it to replace a term in t. And minus 1t, or rather plus 1t, because the 1 here is positive, plus 1t or just t. Take away 2, because we have to write back the constant as well. So negative 4t plus t, or plus 1t, would give us back the negative 3t here. So that's an important observation to make. Now, once we have used the two numbers that we came up with to replace the middle term in the quadratic equation in standard form, the next thing to do is to rewrite the expression in such a way that we pair terms together. So I'm going to pair the first two terms here together, which is 2t squared and 4t. I'll pair them together in parentheses, and then I'll pair the other two together in parentheses as well. And what we're going to do is that for the first two terms here, we're going to try and find the highest common factor. That is, what is the highest term that can go into both 2t squared and negative 4t. what we realize is that 2 can obviously go into itself and it can go into negative 4. And t is also common to t and t squared. So the highest common factor here is going to be 2t. So we'll factor out 2t. When we factor out 2t here, we're going to say 2t divided into 2t squared is going to give us t, because 2 will cancel itself and t into t squared is t. Take away 2t divided into negative 4t. 2 divides into 4 twice, and t divides into itself once, so the t would cancel. And of course the expression here is negative, so this will be minus 2. Plus, there's an invisible 1 in front of the bracket here. Any bracket where there is no visible coefficient, it means that there's an invisible 1 in front of it. So that is where this 1 comes from, in case you're wondering. There's really an invisible 1 in front of any parentheses, any bracket. Just like there's an invisible 1 in front of any variable where there's no visible coefficient. So what we realize here is that the expressions in bracket, the factors in brackets here are the same, which is necessary. The necessary observation to make, and something that we must come up with when we are factorizing quadratics in standard form using this method. So our answer for the factors of this quadratic, our answers are simply going to be this. So our answers are going to be t minus 2, which is the common factor in parentheses here. We just write down that common factor. And my next factor would be simply found by pairing the outer terms, which are in front of these parentheses, which is 2t plus 1. And what you realize is that if you were to multiply out these two factors, t minus 2 and 2t plus 1, you would get back the original quadratic equation here. If you use, for example, the Bird-Beak method to expand these parentheses, you'll get back the original quadratic. So this is the answer. These are the factors of the quadratic. The factors of the quadratic 2t squared minus 3t minus 2 are t minus 2 into 2t plus 1. So what we did here is that we found the factors of 3 different types of expressions. And now it's time for you to take a try. So you will try to factorize these. So you're going to factorize completely. That is the instruction here. Factorize completely. So you're going to factorize completely these expressions. So what I want you to do is to use these questions for practice. And in a follow-up lesson, which I'll post very soon, I will show the workings for these. Thank you for your time. These were questions drawn from CXC past papers where you're asked to factorize quadratic expressions. Thank you for your time. I hope you found this to be a very good lesson in learning. Remember to like, share, and subscribe. See you soon.